This video introduces and defines two commonly used concepts in scientific research that are mentioned in your readings for this week. First, necessary and sufficient conditions, and second, type 1 and type 2 errors. Necessary and sufficient conditions are ideas used to establish causal relations in qualitative research. This is one way to talk about causality when you're not using statistics or experiments. Necessary conditions are factors that are required, or necessary, to produce an outcome. For example, you could say that improving rule of law is necessary to reduce corruption. You cannot reduce corruption without it. Another way to think of this is in reference to concepts and definitions. We can say that elections are a necessary element of democracy. If you do not have elections, then you do not have a democracy. And that's how you need to think about necessary conditions. If they are absent, the outcome is impossible. If there is no X, then there is no Y. Another way to think about necessary conditions is a hoop test. A country needs to meet certain criteria or jump through certain hoops to be considered a democracy. Sufficient conditions are those that, if present, mean you will always see a certain outcome. If X, then Y. Sometimes this is called a smoking gun, a sign that your outcome is always there. Sufficient conditions are very rare. It is more common to say that something is not a sufficient condition, as in, elections are not a sufficient conditions for democracy. Democracy requires more than just voting. The second thing I want to talk to you about is type 1 and type 2 errors. You can find a lot of excellent explanations for this on YouTube, but they tend to get a little more technical. Since I'm really trying to avoid talking about hypothesis testing in this class, here's a very quick, non-technical definition. First off, error is a part of all science. It's not perfect, but science is about having a clear process to test ideas and over time gradually eliminate errors to get correct answers. That's why we talk about quantifying error and the type of error that we're actually producing. Type 1 errors are false positives. This is when you get a positive result on a COVID test but don't actually have coronavirus. Type 2 errors are false negatives. This is when you get a negative result on a COVID test but are in fact sick. So in medical tests, you definitely want more type 1 errors than type 2 errors, just for public safety. And many medical tests are actually set up this way to have an inexpensive or non-invasive test, which has a lot of false positives go first. Then you see amongst those people who tested positive on the first test, have them take a second, either very invasive or very expensive test that's just more accurate. In politics, though, it is much better to have type 2 errors than type 1 errors. It's better to make a mistake by saying you don't think two things are related than to make a mistake by saying two things are a cause and effect when they really aren't. So here's an example of why. There's actually a famous argument in American politics that shark attacks affect U.S. election results. This isn't quite as strange as it sounds. The idea is that voters tend to hold incumbents accountable for how they responded to disasters. This argument has come under criticism, though, for being an example of a false positive. This is a type 1 error. That these scholars didn't do their math properly and proposed a cause-effect relationship that doesn't actually exist. So those scholars could get away with it because they're very famous Princeton professors. But a normal person would do much better not to make big claims and get laughed at about what caused election results without really solid proof. So it's better to miss something that might actually exist than to claim a relationship that is actually fake.